Alright, we are continuing finding areas, but this right here is the area, not just of a pentagon, this just happens to be a pentagon, but of a regular polygon. We've had a whole chapter where we talked about regular polygons in the past. When we say it's regular, that tells us two things. Blake, what are they?
All the angles are equal.
That's right. All the angles are equal to each other, and one more thing. What else? All the sides are equal to each other, okay? So what we're doing right here only works with a regular polygon. Everybody understand that? All the sides have to be equal, and all the angles have to be equal, okay? If you do have that situation, which is a very common situation, by the way, okay, it happens a lot, you can find the area of these things. Let me give you the equation first. There's, out of everything in the equation, or the formula, I should say, out of everything in the formula, you know everything except for one thing. All right, so capital A, what do you think capital A represents? Area equals 1/2. You know what that is. Here's the one thing, listen, here's the one thing that you don't know, that's little a. We haven't talked about that. We'll talk about it here in just a second. What do you think that capital P stands for? Perimeter, that's right. And the perimeter is what? The
outside.
The distance around this thing. If I add up all the sides, that's the perimeter. Okay? What I'm going to show you right now is A. A stands for a word you've probably never heard of, and that would be apothem. Okay? A-P-O-T-H-E-M. Excuse my writing, it's kind of sloppy, but it's apothem. That's how we say it. What in the world is the apothem? Well, I'm glad you asked, because I'm about to show you.
You asked it.
Is that right? If I start, see that dot right there? That dot is in the center of this polygon, this regular polygon. It happens to be a pentagon. All right, that dot's right in the center of it. If I drop a perpendicular to one of the sides, I don't care which side, I just pick this side, it's easiest. All right, that right there is the apothem. I'll put a little A right next to it. Okay, so that is the apothem. Let's make this a little bit thicker. All right, a little brighter. Now it's got to be perpendicular to the side. You follow me? I could actually draw more than just one apothem. That's not the only apothem there's 5 of them, exactly. I could go to here, couldn't I? As long as it was what? Perpendicular. Watch, I'm gonna actually draw all 5 of them. You don't have to do this every time, but since I'm teaching this for the first time, I'm gonna draw all 5 of them.
That was cool.
It does look kind of cool. All right, let's take a look at this. So all of those are an apothem. What do they, look at what they, actually, forget that. I was thinking of something else. We'll just draw one apothem. All right, so there's one apothem. What does it do? It goes from the center, perpendicular to one of the sides of this regular polygon. You guys watching, right? Because I'm thinking right now, I'm thinking of a question that I'm going to put on a test. I know I'm going to put it on the test because it's actually pretty easy, that a lot of the honors kids actually missed because they didn't hear what the apothem was. The apothem is where? It's from the center, and it's perpendicular to one of the sides. You hear me? Do you hear me? Okay. Here's a big hint. I'm going to come back to this. I'm just since I'm thinking about it. All right? Because I'm going over the definition of apothem, and some of you guys aren't paying a lick of attention. And that bothers me because I'm thinking, where would the apothem be right here?
Right in the middle.
And this is a huge hint for a test question. I'm giving a gigantic hint. Where is it from the center? Where's the center? About right there, right? Okay. And then where is it?
Perpendicular to a side.
Perpendicular.
Not an angle, a side, Mr. Mayor.
Okay. Oh, is that right?
Yes.
Okay, good. Thanks for reminding me. So that right there would be the apothem. What if I told you, big hint again, what if I told you what the length of that apothem was?
Then we would know half of the height.
Oh, so why did I just write an A again? Let's make up a number. Give me like 4, okay? What if the apothem was 4? Would you be able to find the area of this thing right here?
Yeah.
Just knowing the apothem?
Yeah.
Yeah, you should, because if this is 4, what is it from here all the way to the top?
8.
So what does that mean the length of this side is?
8.
It's 8. Now this is a regular polygon, so tell me something about all 4 sides. They're all the same. So what's the area of this thing then? It's 64. That's right, because it's 8 times 8, base times height, right? Which is what? 64. Make sense? Okay. That's a
Can you
test
use a regular
question.
polygon formula on a square too?
Boom. It's gone. That's a test question. If you're too slow, too bad. All right, here we go. What?
Can you do that formula? Does that formula
You
work?
could have used that as well, yeah. Blake said, could you use that Apothem formula? Absolutely. Watch. It's 1/2 Apothem times perimeter. All right, so it's 1/2. Now they told you the Apothem already. What was it? 4. Okay. You had to figure out what the perimeter was, right? So what'd you do? You figured out how tall the thing was, right? So if this is 4, then from here to here would be 4. So the whole thing is 8. What's the perimeter of this whole thing? 8, 8, 8, 8. 8 times what?
32.
8 times 4, right? Which is 32. Let's see if it comes out to the same thing. Look, what's half of 4? It's 2. What's 2 times 32? 64, just like we said it was earlier. Okay? Make sense? So could you use that formula? Absolutely. It works, doesn't it? All right. That's the last time you see that until the test, okay? All right, let's continue with this. Let's do an example. Let's use, okay, I did this in the other class. Let's do it in here as well. I made this as easy as I possibly could. Yeah, I'm just making these numbers up. Let's say this is 5, and let's say from here to here, one of the sides, I don't know, we'll just say it's 15, all right? Just picking numbers out of the blue, all right? So if I asked you, if I gave you all this information right here, it really doesn't get much easier than this. It really doesn't. And I don't even know if I'll even have this on a test because it's actually a little too easy. If I asked you to find the area of this pentagon, this regular pentagon right here, what would you do? Well, it's 1/2 times the Apothem times the perimeter. Well, we already know the Apothem. I gave it to you, right?
5.
Okay, so I just stick a 5 right here.
15 times 5.
That's right. So we got to find the perimeter to go here, don't we?
Yeah.
So what's the perimeter?
15 times 5.
Yeah, it's just 15 times 5. Where did I get 5 from? So there are 5 sides. That's right. So each side is 15. We multiply it by 5. That gives you the whole perimeter. What's that? 75?
Yeah.
Okay, so you stick a 75 right here. You multiply all that together, and there you go. There's your area of that whole entire regular polygon. That's just about as easy. I mean, except for me just giving you straight out the perimeter, that's about as easy as this problem gets. It's not going to always be like that, I promise you. Right? It's going to get a little tougher. So let's do one that's just a little bit tougher. I'm going to go to a hexagon. I'm kind of tired of that pentagon right now. 6 sides. Okay, so let's go to a hexagon. And there's a reason why I'm going to a hexagon. It's not necessarily easier to draw the Apothem, but you'll see what I'm talking about. All right, let's look at this. This is 6 sides this time. And let's say they give us one of the sides. Now, on the other problem that we just finished doing, are we listening? On the other problem that we just finished doing, they told you the Apothem. But they didn't actually have to tell you the Apothem. They could have done that problem without knowing what the Apothem was. Brett, stop. So let's say, I don't know, let's say this is 8. We'll make the numbers easy to work with, okay? So let's say that's 8, and that's all we know. That's it. I don't know the Apothem. So what's my formula for area of a regular polygon? It's 1/2 times the Apothem times the perimeter. Well, I don't know the Apothem, do I? But I can find the perimeter pretty easy right here. So let's find the perimeter. If I know one of the sides is 8, how many sides does this thing have? Come on, how many sides does this thing have?
6.
It's got 6. If one side is 8, how do I figure out what the whole perimeter is? 8 times 6, that's right. So it's just 8 times 6, which is 48. Some of you guys are thinking, I thought you have to add up all the sides. I didn't think you multiply. But look, if that's 8, and that's 8, that's 8, 8, 8, 8. What do? You just multiply by 6, right? Because there's 6 of them. So the perimeter is 48. So we're basically halfway done, aren't we? All we got to find now is what? The Apothem. That's the part that's a little bit tougher. And this is where you really need to pay attention and not fool around. Because if you fool around during this, you'll have no idea what to do. But if you pay attention and you take down good notes, then you should have a good idea what to do. This right there is the apothem. That's what we're trying to find. Now, I got to give you a big hint on this, okay? Not just a hint, but I'm going to kind of show you what you need to do. Because you probably wouldn't think of this on your own. But that's what I'm here for. So watch. What I'm going to do is I'm going to draw a line from the center to this corner right here, to this vertex. And I'm going to draw another line to this vertex. In fact, I'm going to do that to all of them. To there, to there. Remember I did this with the apothem, and then I erased it real quick? This is what I was thinking earlier. This is what I wanted to do. Now look at this. What if I started, let's say, here, and I went all the way around to here? How many degrees is that? It's 360 degrees, because we went around a whole circle, didn't we? Okay? But, and you may not understand right now why I'm going to do this, but I want to find what just one of these angles is equal to. Just that angle right there. So if altogether it's 360, how can I find just this one angle? Anthony? That's right, divided by 6. Why 6? 1, 2, 3, 4, 5, 6. So there's 6, and they're all the same, right? All these angles are the same because it's a regular polygon. So I go 360 divided by 6, and what does that give me? 60 degrees. So what is this angle right here? It's 60 degrees, isn't it? Okay. I want to get rid of this stuff because I just showed you those lines just to kind of get you to understand why this was 360 divided by 6. Does that make sense? All right. Now I'm looking at this, I'm like thinking, well, okay, why do I even care what that angle is right there? Well, I got to go one step beyond that. I do care what that angle is, but I only care what this big angle is because I really want to find this little angle right here. Why do I want to find that angle? Because then I can maybe do a trig function or something like that to solve for A, because I've got a right triangle, right? And so if I know one of these angles, I should be able to find this side A. See where we're going with this? All right, so you're right, Brett. The whole thing was 60. What do you think this little one right here is going to be? It's going to be 30, okay? There's reasons for it. Don't worry about the reasons. Just know that it splits that angle in half, okay? So the whole thing was 60, so this little one is 30. What does that make this one down here?
30.
How about 60? Okay, it's 30, 60, 90, right? What about the length of this side from here to here? Anthony, you had a question? Yeah, this side right here would be 4. Good. Because it splits this in half too. Do you see it? This apothem splits this side into 2 equal parts, and it splits this big angle right here into 2 equal parts. So that's 30, and that's 4. Now look at this. You could use a trig function if you'd like.
The short side is...
That's what I would use. Yeah. Well, it's not half. This is the long side, remember? We're not finding the hypotenuse. We're finding this right here. So this is the long side. The long side is what? Not twice. The square root of 3 times the short side. It's really nice when you know these things. All right? You could still use a trig function even if you didn't remember these, but it's nice to know this because what's A? What's the apothem then? It's 4. It's the short side times the square root of 3, right? There it is. Short side is 4 times the square root of 3. That's the apothem. So I just found the apothem without them telling you what it was. The only thing they told you was one side of that regular polygon. And I was able to do a little bit of trig, figure out what that apothem was. If you don't remember this stuff, it's nice if you would remember it. We did go over it quite a bit. But if you didn't, you could use a trig function if you wanted to. Watch. What if I use that 30 degrees? How could I find A if I was going to use this 30 degrees? Well, I've got opposite, and I've got what? Adjacent. Which trig function uses opposite? Tangent. Very good. So it's the tangent of 30 degrees equals the opposite 4 over the adjacent A. So solve for A. Remember how to do this math? Put this on top, put that on the bottom. Who's got a calculator out and ready? Well, I do. I'll use mine. Watch. Let's find out what that is. I just want to show you. You're going to get the same exact thing as you would get for that thing right there. So 4 divided by the tangent of 30. Tangent of 30. And that gives you 6.9. So that is 6.9. What's 4 square root of 3? Let's plug that into a calculator, see what we get. 4 square root of 3. Look at that. Same exact number, isn't it? It's not even off one little bit, is it? It's exactly the same number. So you could have found the apothem by knowing your special triangles, right? Or you could have used it as a trig function. Okay. Turn the heat down a little bit. Or the air on, whatever way you want to look at it. Okay, so we found the apothem. We're still not finished, but that was definitely the hardest part of this problem. So what do we do now to find the area of this thing? Just plug it in, right. 1/2 the apothem, which is 4 squared to 3, times the perimeter. We already found that earlier, didn't we? 48, right? Chuck all that stuff in there, and let's see what we get. Let's see. Half of 4 is 2. Times that is 96. I don't know, I just like it like this. 96 times the square root of 3. And so there you go, about 166.3. So that would be your area. And that's your answer right there, that 166.3. What did we find? We found the area of that whole thing. It was a little confusing, wasn't it? But what'd you have to do? You have to make that triangle. Everybody seeing that? So start here. Draw that triangle. Find this angle in here. What if instead of 6 sides, what if it was 5 sides? That's right. You go 360 divided by 5. What if it was 8 sides? It'd be 360 divided by 8. Everybody see that? Yes? Okay. All right. I'll tell you what. We got a couple minutes. Let me. No, that's it. I think that's it. So your worksheet is section 11.4. Okay, so that's what you're doing tonight, front and back, and that'll be due tomorrow. I think we did one more example in the first period class. So if you really want to look back on the first period class at the end of it on YouTube, you can look at that. We just didn't. We did a little bit more review stuff today than we did in that class. So all right, that's enough. That'll be due tomorrow.